This is Mrs. O'Neill for Chapter 9, Section 2, Part 2, Naming Ionic Compounds. For some of you, this is going to be easier than writing the formulas, and for some of you, this might be a little difficult. Doesn't matter, you need to be able to write ionic compounds, and you need to be able to name those ionic compounds. You should have watched that intro information, and you should have focused on the 5 and 12 seconds to the end of that first part of naming compounds. And here are my notes. So he really talked about two rules for naming ionic compounds. Rule 1, again, you have that positive first part and you have the negative second part. I always think of a compound as first part, second part, having two parts. Then he talked about that second rule about those Roman numerals and how those metals with multiple charges, you need to distinguish which metal you're referring to. So then he did some examples, some with just regular metals, some with that weird positive polyatomic ion. He also did other polyatomic ions as well as those metals with multiple charges needing those Roman numerals. So off to your notes packet. So pause the video, fill in the blanks, read as you write, and then play to hear my words. So the one thing again I want to bring to your attention is that an ionic compound starts with a metal. This is going to be really important because later on compounds are going to be all mixed up and you're going to have to decide what type of compound it is, and it's going to be based off of what it starts with. So that first part of a compound is really important. So again, I break up a compound into first part, second part. First part is always going to be your positive cation. For an ionic compound, it's going to be a metal or that weird polyatomic ion of ammonium. But now when we're dealing with that metal, does that metal have a single charge and you're going to just use its name, or does it have multiple charges and you need to use those Roman numerals that correspond to that charge number? When we're dealing with the second part of an ionic compound, always going to be a negative anion, but that negative anion could be a non-metal. That would be one element ending in IDE, or it could be a polyatomic ion, right, which is going to be more than one element, and you're going to use the name of that polyatomic ion. And I want to remind you that most of your polyatomic ions end in ate or ite, but there's those two goofy ones, cyanide and hydroxide, that are exceptions to those rules. And of course you have that positive one, that other last exception of ammonium. Alright, so again, you're going to use that periodic chart of ions that's at the end of your packet. Keep using that. It's going to make things a lot easier and things are going to come a lot quicker once you start using it and you know where those ions are. So I want to also come back to this charges of multiple charges, right? Your metals of multiple charges. Again, let's focus on here. We have copper and we have zinc. So some of these metals have multiple charges. That's where those Roman numerals come in. But some of these transition metals only have a single charge, and then you don't need Roman numerals. So again, multiple, like your copper 2 versus copper 1, and your single would just be plain old zinc. So let's again remind you of how to crisscross backwards to figure out what the charge of that metal is. So I see copper and I see oxygen, and I don't see any numbers down here. But I want to remind you that that doesn't mean that it's going to be 1 equals 1, right? It just reminds you that those numbers have to be equal to each other, right? Whatever the charges of these two elements are must be equal to each other, because I don't see a number. But that could be 1 and 1, that could be 2 and 2, that could be 3 and 3. So we want to remember when to crisscross backwards. So if we look at our ion sheet, the charge of oxygen is -2. Well, knowing that these two numbers have to be the same, then that must mean that this charge of this copper must have been +2. And if you need to, go back and re-watch that video that deals with metals with multiple charges, because I do a bunch of examples, and again, you can always refer back to your packet as well. So how are we going to name this guy? He's going to be copper 2 oxide. So we need to know what the charge of that copper is in order to name this whole compound correctly. So copper 2, that 2 comes from the charge of that copper. So let's try this one. So again, we're going to look at our subscripts, okay, and now we're going to crisscross backwards. In this case, those subscripts are not equal to each other, so that 2 must have come from that -2 of that anion for oxygen, and if we go this way, then that must have been a +1. So in this case, just because we don't see a number, remember that ones are understood, right? If I asked you how many oxygens are in this compound, you would tell me 1, even though you don't see that number. So in this case, it's going to be copper 1 oxide. Again, I want to remind you that that Roman numeral always corresponds to the charge of that metal. All right, so here are some examples. You might want to listen at least to the first 2 and then pause and write those in, or you can listen to the whole thing and then pause and write in the notes. All right, so we're going to, again, need to know the ion parts in order to name it correctly. And strong suggestion is always to go crisscross backwards, but start with the negative guy. So I'm going to crisscross backwards. I'm going to say, okay, I know that I have Cl. I'm going to look at my periodic table. Cl is a -1 charge, so now I can write that in. And now I'm going to find Na. And again, since I don't see a number here, those numbers must have been equal, and in this case it's +1. So now I can name those ion parts. Na would be sodium, and chlorine changes to chloride. Let's do number 2. Again, we're going to crisscross backwards. So my whole polyatomic ion of SO4 is going to have a -2 charge. Again, that polyatomic ion acts as one component. If you need to, you refer back to those XY examples that we did when we were dealing with polyatomic ions. So then I'm going to crisscross backwards to find the charge of the iron, and in this case it's that 3 from the outside. So if I look on my ion periodic table cheat sheet, the iron with the 3 is going to be iron 3, Roman numeral, and SO4, polyatomic ion on top of your ion sheet, and that's going to be sulfate. So again, at this point, if you want to pause and write those in, feel free, or continue listening. So again, I see Zn and S. I do not see any numbers, but I'm going to crisscross backwards, and I'm going to say, okay, no matter what, when I look on my ion sheet, sulfur is in group 16, so it's going to have a -2 charge. You learn that in chapter 7, or look at your ion sheet. And so crisscrossing backwards, I'm going to find Zn, which is atomic number 30, and it has a +2 charge, which should make sense because I don't see any subscripts here. So when I look at Zn, though, on my periodic table, I notice that it does not have Roman numerals because it only has a single charge of +2. So we can just name it zinc, and sulfur, again, changes to sulfide, something you learned in chapter 7. You learned in chapter 7, or it's on your cheat sheet. All right, here we go. Here's another one now. ClO4, again, that 4 is part of that polyatomic ion. So I'm going to crisscross backwards. I'm going to find his charge on my cheat sheet, and I see it is -1. So when I crisscross this way, again, that 4 is part of the ClO4. So there's no number on the outside, so this must be the copper with the +1 charge. Now I can use my cheat sheet and name it as copper 1, you definitely need those Roman numerals, and then perchlorate. So let me remind you that on your test, when you have to name a compound, it has to look exactly like this. Now, the one thing I don't care about is your capitals or littles in your names, but if there's a Roman numeral, you need it, and if there's not, you don't. So it's going to be right or wrong, okay? There's no in between. There's no partial credit. All right, so why don't you, hopefully you paused the video and wrote all that information in, and now pause the video again if you didn't already, and try these practice problems on your own. So hopefully you try these on your own. The ion parts are just to help you get from the formula to the name. You will not be responsible for giving me that information on the test. However, it really helps you to crisscross backwards and then do the name. Okay, number 2, again, crisscross backwards and then you can fill in the blanks using your periodic table. Again, use that periodic table. You'll have that for your test, and it's going to make things a lot easier to be able to find things. Again, number 3, crisscrossing backwards and naming. And number 4, we're going to crisscross backwards again and get that name. So again, on your test, it has to look exactly like this or it is wrong. There's no partial credit. So, can you do 5 through 8? Hopefully you paused, and I'm just going to kind of click through. I don't think I do the crisscross backwards, so hopefully you got that for your parts, that for your name. That for your parts, that for your name. That for your parts, that for your name. And that for your parts, that for your name. So pause and make sure that you got those correct. Again, it has to be exactly like that. All right, so on your next section of notes, so it's going to be section 2, but part 3, now the ionic compounds are all mixed up. You're going to have binary, you're going to have metals with single charges, metal with multiple charges, and polyatomic ions. So you're going to have to write them and name them. So it's going to be real important that you understand this information. And I believe I have a quick quiz for you. So pause and see if you can come up with an answer. Hopefully that makes sense. Number 2, pause, come up with an answer. And hopefully that makes sense. Again, you're going to have to be able to name compounds and give formulas, and they have to be perfect. That has to be up and down. So again, just a reminder, your capitals need to be capitals, your little needs to be littles, your subscripts has to be on the bottom, and your charges have to be high in the sky. But on your test, I won't really be asking for any of the charges. The charges are going to be for you to help form those compounds and names. And I think this is the last question, so pause. Can you come up with which one is matched up correctly? Hopefully you paused and tried to come up with that. And remember that acetate is that weird guy. Sometimes he's written this way, and sometimes he's written, I call it the choo-choo way, the CH3COO. So it doesn't matter which way, but I do put them both on there because you will see them written both ways. All right, we will see you in class.